Okay, so we are on page 14, 2.3. Like I just said, we're going to be talking a little bit about number theory today. And that's when we look at numbers and we try to find relationships between, different numbers. So what we're going to do is we're going to solve some problems that talk about, like they say, okay, so suppose you have two consecutive integers, right? And then you have to come up with what those two numbers are, right? Okay, so first of all, consecutive integers right, are integers that are in basically counting order, right? So for example, look, 7, 8, 9, those are numbers in counting order, right? You start with 7, and the next one is 8, and the next one is 9, right? So if you were to start at 3, what would be some consecutive integers after 3? Yeah. 4, and then 5, and so on, right? Okay, so basically consecutive, you have to count one after the other. Right, and that's exactly what term we use for consecutive, right? It's numbers that come one right after another. So consecutive means one right after another. Okay, so if I were to start at 7, how many do I go up to find the next one? 1, right? I go to 8. And then from 8, how many do I go up after that? 1 more, okay? So let's think about it another way. From 7, I go up 1. And then from 7, I go up how many to get to 9? 2. And then from 7, I would go up how many for the next one? 3. So I go up 1, then I go up 2, then I go up 3. So one way to write that is if you start at n, right? The next one would be whatever you started with plus 1, n plus 1. The next one would be whatever you started with plus 2. The next one would be whatever you started with plus 3. Okay? So just like here, 8 is what we started with plus 1. 9 is what we started with plus 2. 10 would be what we started with plus 3. So n plus 1, n plus 2, n plus 3.
Oh, we're not doing plus 3 yet.
Right, I had stopped one short for that one. Okay, so those are consecutive integers. So all the numbers, all the counting numbers, 7, 8, 9, 10, 11, 12, 13, and so on. Now, what if you were just interested in consecutive even integers? Can somebody count even numbers for me? Yeah. 2, 4, 6, 8. Right, so from your starting point, how many do you go up? 2, and then from your starting point, you go up 4, and then from your starting point you go up 6, right? So consecutive even integers, first you have to begin with an even integers, and then you count by 2. So if you started with an n, the next one would be n plus 2. Then it would go n plus 4, okay? So suppose we were like a little bit rebellious and we started with a negative number, right? You start with negative 4. Then the next consecutive even integer would be negative 2, then 0, then 2, then 4. You see it? Right, so you still go forward, but you're going, so if this is 0, right? This is negative 4, then you go over to negative 2, then 0, 1, 2, I'm sorry, not 1, 2, 4, 6, and so on. Okay. Now, what if you had consecutive odd integers? Could somebody count up some odd integers for me? Yes. Right? So count up for me. So if you only wanted it to be odd and you started at 1, how would it look? Yeah, 1, 3, 5. A little unconventional because we never really do that, right? We always seem to like the even numbers more. So 1, 3, 5, 7, 9, and so on. So again, if I have 1, 3, 5, 7, how many am I going up each time? 2. I'm still going up 2. The difference is, here I started with an even integer and go up 2. Here I started with an odd integer and go up 2, right? So again, this is your first one, but now it's odd. And then you go up 2, you go up 4, and so on. So if I start at -3, right? So suppose, again, it's on a number line. -3, I go up 2 to -1, then I go up 2 to 1, then I go up 2 to 3, and so on and so forth. Okay? All right. So now let's get right into it. Let's write an equation and solve each of these problems. So look at what it's asking us for. Find 3 consecutive integers whose sum is 21. So how many numbers is our answer going to have? 3 answers, right? Our answer is going to have 3 numbers. And we are told that their sum is 21. Okay. We want 3 consecutive integers. Consecutive means one right after another, right? So what is my first, oh my. So here's what we do. We need 3 integers. So let's see, first integer, second integer, third integer. Okay, your first integer, right? We always start with, what value do we always start with? Always n, right? And now, if it's 3 consecutive integers, just consecutive integers, I go up by 1s, right? So the next one will be n plus 1, n plus 2. Well, now we're going to set it equal to 21, right? So now what we're going to do, we're going to take the first number, add it to the second number, add it to the third number, and all that is going to equal 21. Okay? So look at what we have here. 3 consecutive integers, their sum is 21. Okay? Yes.
Do we know what n is?
We have to find n. That's the point. We have to find n.
Plus 3 equals 21.
Right. So now we're going to combine like terms. So here we have 3n plus how many? 3 equals 21. We can subtract 3 from both sides. So 3n is how much? 18. And now what am I supposed to do? You divide by 3. Right? So n is 6. Okay? Now, n is 6. Right? So is my answer just 6? I need 3 integers, right? So first, second, and third, if I start at 6, my other integers are 7 and 8. So the 3 integers are 6, 7, and 8.
at how we got 7.
Oh, I get it. So pretty much
So n is the first integer.
Equals to 6.
Uh-huh.
And the second one is 7.
Right. So we got that n equals 6, right? N is the first integer. The second integer is n plus 1.
It's consecutive. So
6 plus 1 is 7. The next integer is n plus 2. 6 plus 2 is 8. They're consecutive, so they're going to come one right after another. Okay? Yeah.
So let's say instead of having.
Okay, now we want 4 consecutive even integers. So let's just first concentrate on that one, right? First consecutive even integers. So we want the first integer to be n. Okay? Second even integer. Remember when you go evens, you're going to go up by 2. So it's n plus 2. The third even integer is n plus 4. And the fourth even integer, n plus 6. Good. Now, it tells us that their sum is 92. So if I add all these, the sum is 92. All right? So you see how I'm talking it out. So the first number, the second number, the third number, and the fourth number is equal to 92. All right, let's do some like terms. 1n, 2n, 3n, 4n. A 2, a 4, and a 6, right? 2 plus 4 is 6. Plus another 6 is 12 equals 92. Let's subtract 12's 4n, 80. Divide by 4, divide by 4, n is 20. Where here on my list is 20? First, second, third, fourth? First. So then the next one is? I'm going to go up by 2's. Remember, these are all the even consecutive integers. Even. Whoa. Just a second. Why is it doing that? Okay, here we are. So, even consecutive integers means go up by 2. So, 20, 22, 24, 26. Okay? So these are the 4 even integers. All right. Yes. So work on number 1 alone, and then we'll get back together and see how we could solve it. Okay, so just number 1 and then stop. I'll pause this for a minute. So before you start, okay, if it just says consecutive integers, then you're going to add 1. If it says, if you see the word even or odd, you're going to add plus 2, right? You're going to go n plus 2, n plus 4, n plus 6.
Yeah. And how do we know, like, how many, like...
If there is no even or odd, then you're just going to do plus 1s.
How many?
How many? That's from here. So if you're looking for 3, 3, 3, so it looks like all of these, you're looking for 3 of them. Okay? Yeah. If you want to find 3 numbers, I would just start with this. First, second, third. Now, your first is always n. Always. Then you ask yourself, does it say even or odd? Does it say even or odd? No. So I need to go from n, I need to go up by ones. So if I go up by ones, what's the next one? N plus 1, n plus 2. Then I go, okay, that's all fine and well. What's going on with these numbers? What do I know about these numbers? What do I know about these numbers? Right? And how much do they add up to? They add up to 42, right? So then I say, okay, their sum is 42. Right? So now the next step is add them all up. Here's the first one, and the second one, and the third one, and they go to 42.
How do you combine the n? You just like how do you do that?
Combine like terms, so here's how I do it. 1n, 2n, 3n. And then I got a 1 and I got a 2. First of all, let's finish this one. 3n was 39. Divide by 3, divide by 3. So n is 13. I think most of you got this one.
Yeah.
So the integers are 13, 14, 15. Okay, now, so take a look at here, this next one. How many numbers am I looking for here? 3. So I say first, second, third. Now, I'm looking for consecutive even integers. My first one, the first one is always n, no matter what. Now here it says even. Whenever you read the word even or odd, you're always going to do n plus 2, n plus 4. Now, check it out. This next one, how many numbers are you looking for? 3. First, second, third. What's the first one always? N. Do you see the word even or odd here? Right, so there is an even or odd. It doesn't matter if it's even or odd. You're still going to do n plus 2 and n plus 4 just like you did this one. So, right. So that's the thing. You always go up by 2's. Is that right? So if I start at 1 and I want the odd numbers, how many do I go up for the next one? 2. So if it's 1, 3, 5, 7, how many do I go up? 2. How many do I go up? 2, right?
Wait, for number 3, aren't those supposed to be odd?
Oh, I know why.
Yes.
Because you start on an even.
You start an odd here, you start an even here. So whether it says even or odd here, you're still always going to go up by 2's. The difference is, when you're counting by even ones, your first number is even. When you're counting by odd ones, your first number is odd.
But right here, the first number is even.
How do you know? It's
Oh,
n.
sorry.
You don't know,
Sorry.
right?
I thought you meant
Yeah.
the seconds.
Right. Okay. So, do you see how? So, when I'm teaching math, I always want to tell my students, search for patterns. So, do you see how there are two different problems, but they're solved the same exact way?
Yeah.
So, no matter if it's even or odd, you're still gonna do n plus 2, n plus 4.
Why is that?
Well, the reason is, if you're looking for even ones, you start with an even number, like 4. And then how many do you go up for the next one? 2. And then how many do you go up for the next one? 2. When you're looking for the odd ones, you start with an odd number, but still how many do you go up for the next one? 2. right? You always go up 2. The difference is where you start. Okay? Yes. So let's solve number 2 first. So n plus 2, n plus 4 equals negative 12.
Oh, I get it.
Yeah?
I think I.
So how many n here? 3n plus 6 equals negative 12. Now, somebody help me out here. If I subtract 6, what am I going to get? Negative 18. Thank you. Hall pass. Now, when I divide, n equals negative 6. And most of you, yes, you got negative 6. Now, okay, so the 3 even integers are negative 6, and now I need to go up to negative 4, and then I need to go up to negative 2. Okay? Here, when I add all these, what is the sum going to be? 33. So, when I add them all, how many n's do I have? 3 n's. And how about the numbers? 6. So help me out. What do I do? Uh-huh. So n equals 27. Then somebody said, I'm sorry, 3n. And somebody said I need to divide by 3. Right. Do you see how it came out to an odd number? Even though we did plus 2 plus 4. Isn't that like amazing? It's like magic. Right? So always trust in the math.
Different type of sum.
Right. So the 3 odd integers are 9, 11, 13. And now your final step should be to see if your answer makes sense. So I have 3 little boys, and when they're, when they are working on their math problems, I say, okay, does your answer make sense? So I'm looking for 3 odd integers. Did I get 3 odd integers here? Yes, I did. Okay, so my answer does make sense. Okay? Okay.